Have you ever noticed how sometimes time just seems to fly by?
And other times, it just drags on forever.
It's like 1 minute you're starting a new project, and the next, it's deadline day.
Or you're waiting for something and every second feels like an hour.
It's such a weird feeling, right?
It is. But that feeling, it's just scratching the surface of what time actually is.
Exactly. Today, we're taking a deep dive into the nature of time itself.
And how we experience it.
We've got some amazing source material from you, our listeners, a scientific look at how our own bodies affect our perception of time.
A mind-blowing conversation with Nobel laureate physicist Frank Wilczek.
And even a discussion about the possibility that time, well, might not be fundamental at all.
But rather something that emerges from the underlying reality.
So our mission today is to bring all of these perspectives together.
To give you a deeper understanding of what time might actually be.
All right, let's kick things off with something we can all relate to.
Ourselves.
Our own bodies, actually.
That's right. One of the sources you shared explores this deep connection between our internal states.
And our perception of time.
It's like our bodies have their own internal clocks that influence how we experience time externally.
So are you saying that our physical well-being directly translates to a better sense of time?
Not exactly. It's not a one-to-one thing.
Right.
But there's definitely a link between our internal bodily states, things like body temperature.
Hormone levels, metabolism.
Precisely. And how we perceive the flow of time.
So our heart's beating, our lungs are breathing, our stomachs are digesting.
And that's all tied into how we feel time passing.
Why? You know, the source mentioned some examples that I think we've all experienced, like when you're stressed,
You're really excited.
time can seem to speed up.
Or slow way down.
It's almost like our internal rhythm gets thrown off.
It does. Those situations often involve a challenge to our body's natural balance.
What's called homeostasis.
Exactly. And our brains are always monitoring these internal signals.
I make sure everything's running smoothly.
Right. And research suggests that the parts of the brain responsible for this monitoring.
Like the insula and the anterior cingulate cortex.
Yes. Those areas also seem to be involved in our sense of time.
So it's like those brain regions are working double duty, keeping our bodies in check.
And also keeping track of time.
Pretty impressive multitasking.
It is. They integrate those signals from our autonomic nervous system.
Which controls all those automatic functions our bodies do.
With the cognitive processes we use to consciously track time.
So if our internal state shifts, it can actually tweak those neural circuits that govern our sense of time.
That's the idea.
But there's a crucial point that the source makes.
It's not just about homeostasis.
Right. It's way more complex than that.
Our attention, memories, and emotions all play a huge role in how we perceive time.
Think about it. When you're engrossed in a good book or a movie,
Time can just vanish.
even if your body is perfectly balanced,
Right. On the flip side, if you're anxiously waiting for something,
every minute feels like an eternity.
regardless of your physical state,
Don't forget about new experiences,
they often seem to fly by in the moment.
because our brains are busy processing all that new information.
But later on, when we look back, those experiences can feel much longer.
Packed with memories.
Exactly. So it's like our bodies provide a base rhythm for our perception of time,
But then it gets modulated
sometimes even completely overridden.
by all sorts of other factors.
It's a dynamic interplay between our internal state.
And the world around us.
Precisely.
So we've established that our bodies definitely influence how we experience time.
But what about time itself? What is it, really?
Right. Let's zoom out now and consider this idea of time as an emergent property.
Which is discussed in the Brian Greene clip you shared.
It's a pretty mind-bending concept.
It is. Think about temperature.
We all know what hot and cold feel like.
But if you dig deeper into the physics, temperature isn't this fundamental thing on its own.
What do you mean?
It emerges from the average motion of all those tiny particles that make up matter.
Atoms and molecules.
Yep. If those particles are zipping around with lots of energy,
We feel that as heat.
and if they're moving slowly...
Feels cold?
Exactly. It's like a traffic jam.
Okay.
The traffic jam isn't caused by one single car. It emerges from the collective behavior of all the cars.
So temperature isn't a basic ingredient of the universe.
It's a result of how other basic ingredients are behaving together.
Okay, I get the analogy. But how does this relate to time?
The big question is, could time be similar? Could our experience of time as this continuous forward flow
Be an emergent property, too.
maybe there are fundamental components of reality?
Like atoms of time.
Not necessarily literal atoms,
Okay.
but perhaps some fundamental aspect of the universe that When arranged in certain ways.
They give rise to what we perceive as time.
Exactly.
Wow. So you don't have enough of this fundamental stuff, or it's not arranged the right way.
Time, as we know it, might not even exist.
That's a huge implication.
It is, in environments that are drastically different from our own,
Like the very early universe.
or inside a black hole.
Those places might not have the right conditions for time to emerge.
Exactly. Time might be specific to our kind of universe, our corner of reality.
That is mind-blowing. It makes you think that our everyday experience of time,
Might be more like a local phenomenon.
a side effect of the complexity we're surrounded by.
Absolutely. It challenges the idea that time is this universal, unchanging backdrop for everything.
And suggests that it might be a feature that arises within certain systems.
That's the idea.
All right, so we've gone from our bodies shaping our time perception.
To the possibility that time itself might not be fundamental.
Now, let's hear what a real expert in physics has to say.
A Nobel Prize winner.
Exactly. The conversation you shared from Quantum Magazine with Frank Wilczek.
It gives us another really insightful perspective on time.
It does. Wilczek really understands how time is represented in the fundamental laws of physics.
And he grapples with the philosophical questions about it, too.
He starts off by reflecting on his own journey through time.
Marking 50 years since his first scientific paper and his marriage.
It's a really nice, relatable way to start.
It is. He connects with the human experience of time's passage,
And then he dives into the physics of it all.
where time, represented by that little t in equations, acts like this master variable.
Controlling how everything evolves.
Right. In physics, time is the parameter that governs change.
The equations describe how things transform over time.
Exactly. But Wilczek highlights a really important difference between that mathematical time.
In our lived experience,
We can mentally travel through time with memories and anticipation.
in a way that physical objects bound by those equations can't.
It's a profound difference. Think of a ball rolling down a hill.
It just follows the laws of physics, forward in time.
But we can remember seeing that ball roll yesterday.
Or imagine it rolling tomorrow.
We have this ability to access the past and future.
That adds a whole other layer to our understanding of time.
Absolutely.
And then Wilczek gets into some of the big mysteries surrounding time.
Mysteries that have puzzled physicists for ages.
Like the fact that the fundamental laws of physics seem to be reversible in time.
Yet our experience of reality clearly isn't.
It's one of those things that just doesn't seem to add up. The laws say things can happen forwards or backwards.
But we never see a broken glass spontaneously reassemble.
Exactly. Why is that?
It's a deep question. While the fundamental laws might be almost time symmetric,
The world we experience is very much time asymmetric,
it makes you wonder why the laws have that property in the first place.
and how it fits with what we observe.
It does. And this is where the idea of the arrow of time comes in.
That feeling that time only moves forward.
Precisely. Wilczek talks about several different arrows.
Like the psychological arrow, our subjective sense of past and future.
The thermodynamic arrow, the universe's tendency towards disorder or entropy,
The radiative arrow, with waves spreading outward.
and the evolutionary arrow, with life evolving from simpler to more complex forms,
It's amazing to think that all these arrows might be connected.
unified by something even more fundamental, the cosmological arrow of time,
Which is tied to the Big Bang and the universe's evolution from a very uniform state.
to the clumpy, galaxy-filled cosmos we see today.
It's driven by gravity, that force that pulls everything together.
Right. And think about entropy. It's a measure of disorder.
Like a dropped glass shattering into a million pieces.
It's much easier to break something than to put it back together.
That's true.
The early universe was in a state of very low entropy, very uniform, and ordered.
But gravity favors clumping, pulling things together,
So since the Big Bang, the universe has been moving towards higher entropy.
becoming more disordered.
And Wilczek suggests that this overall evolution of the universe,
Might be what underpins all the other arrows of time.
it's a mind-blowing idea. The reason we remember the past but not the future,
Could be connected to the Big Bang itself.
to the universe's journey from order to disorder.
That's a pretty wild connection.
It is.
Now, Wilczek also brings up this thought experiment. Imagine a universe where absolutely nothing changes.
No motion, no interactions, nothing. Would time still exist?
It's a really deep question. Is time something inherent to reality?
Or is it dependent on things happening?
What do you think?
Wilczek actually suggests that even in that hypothetical universe where nothing is changing,
Time would still be present in the equations,
almost like a potential waiting to be realized.
like a seed that hasn't sprouted yet.
He uses this great analogy of a smooth flowing river.
Okay.
If you look at it from the outside, the overall flow is constant.
Nothing's changing over time.
But if you could follow an individual water molecule,
It would be moving, constantly changing position.
even though the overall flow pattern stays the same,
So even in a seemingly static universe, if there was some internal observer,
something experiencing that underlying reality.
it might still perceive the passage of time.
Exactly. It's like, are you watching the river from the bank?
Or are you in a boat moving with the current?
Both are valid ways to see the river.
And maybe the same is true for time, even in a seemingly unchanging universe.
It's a powerful way to think about it.
Then, Wilczek moves on to this famous definition of time,
often attributed to Ernst Moff.
and later echoed by Einstein. Time is what clocks measure.
But it's important to remember that the word time can be pretty vague.
In everyday language,
Right. When physicists talk about time,
they mean something very specific.
a precise scientific concept.
Okay?
And to understand what it means for time to be what clocks measure.
You have to broaden your definition of a clock,
It's not just about those things we have on our walls.
or on our wrists,
A clock, in this sense, is anything that undergoes regular change.
according to the laws of physics.
Exactly. The Earth orbiting the sun.
A pendulum swinging,
Even radioactive decay.
those can all be considered clocks,
And what's amazing is that all these different kinds of clocks,
with completely different mechanisms.
if they're calibrated properly, they all agree on the measurement of time.
It's pretty remarkable.
It is. It shows a fundamental consistency in the laws of the universe.
And speaking of consistency, it's fascinating how our ability to measure time accurately,
Has been so crucial for scientific progress.
as Wilczek points out with Galileo, Newton, and Kepler,
Their groundbreaking work on motion and gravity.
was deeply tied to advances in timekeeping.
Absolutely. The scientific revolution was partly a revolution in our ability to measure time.
To quantify the temporal aspects of the universe.
Precisely.
And then, of course, we have Einstein.
And his truly revolutionary ideas about time.
His theories of relativity completely changed our understanding of time,
They did. First, with special relativity.
where time and space become intertwined as space-time.
And time itself becomes relative to the observer's motion.
What one person perceives as purely time.
Someone else, moving relative to them, might see as a mix of space and time,
It's a huge shift from Newton's concept of absolute time.
where time is this universal, unchanging background for everything,
Einstein showed that time is flexible,
dependent on your frame of reference.
and things get even weirder with general relativity.
Where gravity is understood as a curvature of this unified spacetime.
Different observers in different gravitational fields.
They experience their own unique mix of space and time.
It's like, imagine a stretched rubber sheet.
If you put a bowling ball in the middle, it creates a dip,
That dip is like gravity warping spacetime.
changing how objects and even time itself move around it.
It's hard to wrap your head around.
It is. But even though these relativistic effects might seem abstract,
Confined to those extreme realms of superspeeds and massive gravity,
they actually have real-world consequences.
like with GPS.
Exactly. GPS relies on super accurate clocks in satellites orbiting Earth,
To function properly, it has to account for those time dilation effects.
predicted by special and general relativity.
If we didn't make those corrections,
GPS would be wildly inaccurate.
it brings Einstein's thought experiments about clocks right into our everyday lives.
It does. It shows that these seemingly abstract ideas about time,
They have tangible effects on the technology we use daily.
it's pretty incredible.
It is. And to wrap things up, I found it super intriguing how our understanding of time,
Might be connected to this whole mystery of dark matter.
through the concept of axions.
That's an exciting area of research.
Axions were originally proposed to solve a puzzle in physics,
About why the fundamental laws seem almost perfectly reversible in time.
even though the world we see is clearly not.
Right. And it turns out these hypothetical axions,
Might also explain dark matter.
that mysterious stuff that makes up a huge chunk of the universe's mass,
It's a great example of how different areas of physics can intersect.
and maybe offer solutions to multiple mysteries,
And there are experiments happening right now.
trying to detect axions.
Wilczek seems optimistic that we might find something in the next few years,
It would be a huge discovery
linking our understanding of time's fundamental symmetries.
to the nature of dark matter.
It's pretty amazing to think about.
It is.
So as we come to the end of our deep dive today,
We've explored the many faces of time,
how our bodies influence our experience of it,
the possibility that time might not be fundamental at all,
and the mind-blowing insights of modern physics,
where time is relative, flexible.
and maybe even connected to dark matter.
It really challenges how we think about something so fundamental to our lives.
It does.
What part of our discussion resonated most with you?
Were you surprised by how our bodies affect our sense of time?
Or the idea that time might be emergent?
Or maybe the implications of Einstein's theories?
It's a lot to consider.
It is. And it leads us to a final thought for you to ponder. If our perception of time is so influenced by so many things,
And its true nature is still being explored.
how might our understanding of time continue to evolve? Could our experience of the present moment
Of now,
be far more fluid than we currently think? Think about how different conceptions of time might impact psychology,
cosmology.
even our personal lives.
It's a truly deep dive into something we often take for granted.
And it makes you wonder what the future holds for our understanding of time.
It does. It's an exciting time to be thinking about these questions.
That's for sure. And thanks to you, our listeners.
For the thought-provoking source material.
It's been an incredible journey through the mysteries of time.
It has. Until next time.